Alright, working on a twin this morning. Most of y'all still asleep. I would be if I was your age. Alright, I'm not going to do number one. You need to just pick up a calculator and figure it out. At least 5 of you will write that and turn it in. That's what you'll do. Oh, God love you. Alright, augmented matrix. Easy problem. You know, this will be a test. It'll mostly be multiple choice. Shouldn't take you too long. But you've got an X column, you've got a Y column, you got a Z column, and you got your coefficients. All right. The X's are a 4. That one's got a -2, and that one's got a 4. The Y's are a -8. This one has a 3. This one has a -2. This guy has to be moved over. Oh, by the way, the first one has no Z. That one's got to be moved over, makes it negative. That one's fine where it's at. Coefficients are 12. You know, when this guy got moved left, there was literally nothing on the right. So 0, 12. Form the row operation. Row 2 is -4, row 2 plus 4, row 3. All right, so I'm going to multiply this row 2. This is row 2, by the way, if you have no idea what's going on. I'm going to multiply it by a -4. It's going to be -12, -8, 4, -20. And I'm supposed to add row 3, and row 3 is 3, 2, 1, -2. And I just add down. -9, -6, 5, -22. And this is what row 2 is. I just need to find if it's multiple choice, a matrix that has that. Solve the system. You can use row operations or inverses. I'm going to use row operations. System has no solution. State that is inconsistent. So it works a lot like number 2. I'm going to write an augmented matrix. I'm going to see what my TI-84 says about it. She is a 3x4. She has 3 rows. She has 4 columns. That's as dark as I can make it. Quit. We're good at that. Second matrix math. Looking for that RREF command. Second matrix A. This one's interesting. Here's my result. Let me check and make sure I had everything in it right. Yeah, I'm good with that. All right, so let's talk about what things are saying. This line says no Z is 0, which means Z is an element of the real. This line says 0Y is 0, which means Y is also an element of the real. So both the Z and Y are any real numbers. And then we have this top line. It says X minus 3/2 Y minus 1/2 Z is 2. And I'm just going to solve it for X. I'm just going to move those guys over. X is 3/2 Y plus 1/2 Z plus 2. Now I can think about my order triple. My order triple would have the X value, 3/2 Y plus 1/2 Z plus 2, followed by Y as an element of the real, or Y as any real number if you got time space to write it, followed by Z as an element of the real. So it is definitely a dependent system. All right, I'm going to RREF this one real quick. This one should have some nice answers. Second matrix edit, still 3 by 4. Hopefully what you realize is I'm just typing in the coefficients that are in front of the variables. It's probably kind of small on a phone to see. And I can't make the glare any lower. There's just nothing I can do about that with this calculator. It's just a bright lit display. But I'm checking and making sure I got everything in. If you don't have a TI-84 yet, you need to go talk to the librarian. She has them. Oops. All right, that looks like everything. I quit. Second matrix math, hit the up arrow, 2 below come sum. Second matrix A, and my result of the reduced row echelon operations, or at least the operations to get me into reduced row echelon form, is this. This one's a nice easy one. It literally says x is 5, y is 1, z is -2. So my order triple would be 5, 1, -2. Another Kirchhoff's rule. If you saw the first one, these aren't that bad. Think about what happens to this as it moves over. All right, you'd have negative I1 plus I2 plus I3. In the previous video, I spent some time rewriting this as x, y, and z. I'm not doing it. All right, I'm just not doing it. That makes 40, and when you shift it from the left to the right, it's now negative 40. That needs to be moved from the left to the right. That makes it negative because you jump equality, your sign changes, and then we're ready to write a matrix. There's a negative current 1, a positive current 2, a positive current 3, and now a 0 on the right-hand side of equality. There's a negative 6 current 1s, a negative 6 current 2s, there are no current 3s, and there's a negative 40 on the right side. A negative 6 current 1s, there are no current 2s, a negative 3 current 3s, and a negative 24. And again, we're going to RREF this thing, reduced row echelon form. So second matrix edit, also a 3 by 4. Now I've just done 3 problems in a row that require you to understand how to literally just push buttons in a TI-84. That's what you do. I mean, that's what you do. Or you're going to have to do it by hand. I mean, whatever. I got some interesting numbers there. Wasn't expecting that. I wonder if I made a mistake. Oh, I did. It's right there. I'm an idiot. That's negative 36, isn't it? Why did I write 40? I don't know. Try this again. Probably because it's so early in the morning. 100.3.5, 010.2.5, 0011. And my first current, I subscript 1, is 3.5. My second current, that's probably in amps, by the way. My second current is 2.5. And my third current is 1. All right, that one's done. Ceramics Workshop makes wreaths, trees, and sleighs for sale at Christmas. You got to pay attention to the information they give you. You need to kind of group things that are like, here we have hours, 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 and the workshop dedicates 100 hours to prep time. So that's one equation. There's literally an equation about hours. I'm just going to go straight to to the matrix form. 5, 12, sorry, that's hours of prep. This is prep time. Equals 5, 12, 5, 100. So that was talking about prep time. The next thing we see here is paint. We have a 3, a 3, a 5, and an 80. And then the next thing I see is firing, where they bake these things. All right, so there's a 6, a 5, a 6, and 140. And we're supposed to figure out where all these things intersect, because that's how much they're going to make of each thing. And we're going to get some fugly numbers here, because I just made some stuff up. I didn't spend 10 minutes trying to get this thing to come out with whole numbers. If it comes out with whole numbers, that's amazing. It's just pure luck. It is a practice question. I could care less if the answer makes any sense or not. I don't. It's just practice. So I got something funny there. What's real funny is one of them's negative. Isn't that kind of interesting? This is saying we're going to make negative trees. Yeah, something's wrong with that. Make sure that I've got some lines right here. But 5, 12, 5, 100, 3, 3. Well, this should be an 11. Still negative. Well, all right. Looks like I found a typo. Still have negative 2.12 trees. Interesting. And 1.38 sleighs. Looks like most of the stuff they're going to make is wreaths. And somehow or other they're going to make negative trees. Anyways, it wasn't supposed to work out nice. Wasn't intended to. Solve for x. This notation means determinant. So you're going to do 4 times x. Take away 2 times a negative 6. And it must equal 12. 2 times a negative 6 is negative 12. But a negative times negative is positive. We're going to subtract 12. 4x is 0. Divide by 4. 0 divided by anything is always 0. So there you go. The x value that makes this true is 0. Consider the vectors, vector v, which is 2, 7, and vector w, which has component form negative 5, 9. What are the component form, magnitude, and directions of vector v plus vector w? So vector v plus vector w would add the x components and would add the y components. 2 plus a negative 5 is going to be a negative 3. 7 and 9 is going to be 16. So that is the component form. The magnitude, denoted with kind of the absolute value bars here, happens when I take these numbers, I square them, stick them under a square root. And 3 squared is 9, 16 squared is 256. So what are we looking at here, 265? No, yeah, 265. Root 265. It says you can round to the nearest tenth. I don't even know why I was writing it out, but whatever. 16.3. Whatever the units are. And we have direction. Theta, the angle, is always going to be the arctangent of x over y. I'm not going to worry about drawing it. I don't care if you draw it or not. Theta is always going to be the arctangent of x over y. So we have a 3 and a 16. So the arctangent of 3/16. I would not put the negative angle in. Last year you were not taught about negative angles. They don't make sense to you probably, so I wouldn't mess with it. It's about 10.6 degrees. Make sure your calculator is in degree mode, obviously. This one was. What is the area in square units of a triangle defined by the vectors 4, 7, and -5, -12? So the area of a triangle using determinants is 1/2 the absolute value of the determinant matrix. And this would have an upper row of the x values and a second row of the y values. And then you just figure it out. 1/2 the absolute value. 4 times -12 is -48. We're taking away 7 times -5, -35. So it's going to be a relatively small number. It's 1/2 the absolute value of -13, which is 13 over 2, because I make it positive, or 6.5, and it's square units. Assuming I didn't make any mistakes. I'm really tired, so I probably have. If I have, fix them. I ain't got time for a redo. Stop that video there real quick. It's getting large. I'd hate for it to crash and me lose everything.